Welcome to Neon Cobra. Let's kick into it. Great. So continuing on the common estimate browser, we're going to hop in today and we're going to do a GPU or graphics enabled workload. So you generally see these for SolidWorks, design and engineering firms, tend to be the more traditional ones, LiDAR. Occasionally see a lot of people maybe even doing AI stuff, which has been really cool to kind of help quote out lately. But what we're going to look at today is just building a traditional, we'll say SolidWorks type CAD design workload. So we're not going to cover too much today. We're going to hop over to the pricing calculator, and we're actually going to take one of the existing ones we built earlier, because really the only major change to this is going to be around the type of AVD we deploy, right? And I'm going to talk about some of the considerations around that. So we're going to take the 50 user Sage copy here, and we're going to copy that out. And then once that copies into our section here, we're going to open. And we'll take an opportunity to rename this so it makes sense. And we're going to call this 50 user, call this engineering. So a quick high level of what we did before, and this is why we organize it the way we do. We're using the entry domain services. We've got a Sage 300 virtual machine. We've got our QuickBooks data. We've got our file storage. We've got our 50 user AVD. We have all this extra information like the Azure firewalls and such. So if you're curious how we got to this, the previous video will be linked in the comments below. Feel free to go watch to find out how we got here. Now, the biggest change we're going to do, let's say this user farm of 50 does use Sage 300. So we're not going to touch the original virtual desktop, but we're going to add a second one, right? This is something that you'll likely want to do a lot of times when you're designing for these types of environments, because you don't want all 50 users using, right, your heavy graphics enabled users. You want to make sure that if you're using this, it is scoped right down to the user that will use. And this will make sense in just a moment. So we're going to go in, we're going to expand this out. We're going to say of that 50, let's say we've got 10. So 10 engineerings. We'll call them NGs, right? Just to keep it clean. Now, the workload type is, again, something we're going to probably have to come back and modify first. But as mentioned previously, this is really going to be a means to an end to force the scaling we want to see. So we'll come down, and we're not going to use an E-series. These are not graphically enabled. We're going to want to go to the GPU section. Now, this is very important, right? And we're going to pull up another window here in just a moment. But what you're going to find a lot of times is the region you choose matters, right? Canada Central has a lot of GPU enabled units, but not as much as some others in the US. And Canada East, last I checked, doesn't have any. So if this is Canada East, and this is where I probably put a foot in my mouth, depending on what's been deployed there. Aha. So they finally started deploying. However, these would be terrible units to put engineers on because it is high transaction. It's 96 vCPUs and 1.9 terabytes of memory. These are high compute units. So if you were in Canada East, that's your only option. You don't have to bridge networks. You have to bring people over to Canada Central. So if you're forward planning this stuff and designing, regions matter, and you sometimes have to go further away from your location to get what you need. Now, back in Canada Central, we have a bunch of different ones, and they are extremely difficult to navigate compared to others, right? E's and D's, I have those sizing videos of how to choose through those. Those tend to make a little bit more sense. What you'll find a lot of times you're looking at this is you don't know, right? Not all GPUs are made the same. Some are for virtual desktop optimization, some are for gaming, some are for AI and large data modeling, right? You have to find one that makes the most sense. What I do know when sizing for SolidWorks and AutoCAD and such, the A10 series are probably the best bang for your buck and make the most sense. Now, at least in Canada Central, there may be some other options out there. But what I want to show, and I'm going to just slide this over here momentarily, is you need to actually go through the documentation from Microsoft. So I'm going to share this out quickly, and I need you to see. So under the virtual machine sizing page, and I'm going to send this as part of kind of the links, I've linked it in the past, but you're going to want to go down to your GPUs and your overviews, and they're going to be sorted into families. So when you're doing this through families, you need to understand, well, look, if I'm doing compute intensive or graphics intensive, this is probably where I want to be, right? If I'm doing gaming, virtual game streaming, things like that, or VDI, maybe you go down to one of these. More often than not, though, you want to stay with the NC family. Now, I had looked at, the NV family, the virtual desktop VDI, single precision compute, video encoding and rendering, right? So this is where you kind of want to find out where you want. If you go to the A10 series, you're going to get a breakdown of kind of what's under the hood. This is also very important because some of these come with AMD cards and AMD chips, and not all design software is compatible with AMD GPUs. So what I do know about the NV A10s is that they use an A10 GPU under there. And then you can go into the series page and you can see the specific designs. So the one we're looking at right there, the 6-core 55, right? You can go across the top. It's only giving you 1/6 of the card, or 4 gigs of memory. So this is when you get like your requirements from, say, SolidWorks. I keep using them as an example. Any AutoCAD application, and when they bring it out to you and say like, look, we need 8 gigs of memory. If you do the baseline, you're only going to get 4 cores in 4 gigs. Now, the reality is they like to ask for this stuff because they're likely not getting these A10 cards. They're getting like, GPUs, like the GTX series and things like that from like your local Canada Computers or Memory Express or something. If you're doing this in Azure, these are enterprise grade cards. You can pull the throughput and they likely will work better than your over the counter kind of stuff. So when you're looking to size, this is very important. It's a very necessary step when you're coming through this kind of stuff. So make sure you have this bookmarked if you're designing. So with that in mind, we're going to do the A10 series, right? It's running that A10, 4 gigs of processing memory. Now, this has 6 cores and 55 gigs. So what this would tell me on the power user, I'd get 2 hosts on these ones, right? What I have found with these systems, especially with engineers, they can be very demanding in their resources, not just as people, which engineers can be, jokes aside, but the actual application, they need that throughput. They need that power. So putting 6 users on this isn't a great idea. I'm going to blow out this density somehow, but I can't adjust my power workload more. So what do? You start playing with the total named users, right? You're using this as a means to an end. 10's an arbitrary number. What I want to see, I want to put 3 users per, right? So in that case, I need 4 virtual machines for this to happen, right? You could probably get away with 3, but just for sake of argument, we're going to say 4. So then I'm going to bump this number up to 20. And that's going to force 4 instances now. And this is where you can decide whether you want to scale, what's my on-off hours kind of thing. But for sake of argument, I'm going to look 3-year reservations. Just keep all 4 hosts on $1,000 for that. So 10 users for about $100 a month Canadian will get GPU enabled units. Everything else will likely remain the same, right? They don't need large OS disks. Occasionally they may if something needs to run locally, but more often than not, you can scale like that. Adjust your database sizing. For 10 users, we'll just do 200 gigs, right? Again, this is profile space. Your app servers will be housing the actual data you're accessing, so I wouldn't worry too much about that. Egress, you may want to include some of this as well. If you have 2 AVD hosts, right, you tend to do 5 to 7 gigs, we'll say, for heavy usage on graphic-enabled units, right? If they've got multi-monitors and such, right, you're pushing a lot of bandwidth through there. But even then, 10 users is like 50 gigs. So keep padding in there as needed, but it still likely won't make an impact for 10 users. And that will be the AVD line item for GPU-enabled workloads. Now, regardless of whether you're using the AVD side or doing personalized desktopping, the point to take away is identifying the instance series that makes sense to you. These NVA10 models were only made available, I want to say, a year and a half ago. We traditionally were going with the NVV4 series, which has a weird split out of how the resources would work. So like it had low core to memory and AMD cards under the hood. So a lot of specific CAD-based softwares would have difficulty actually loading this stuff up. So this has been a boon to the Canadian region at the very least. But to bring that all down, again, make sure you go through there, you identify. So We're talking from an ROI perspective, right? On average, $100 per user per month. If you're looking at a CAD system, right, those systems can anywhere from $4,000 to $6,000 Canadian per user. So now we're doing a more of a spread out approach, and you're always going to get the best bang for your buck. And then to finalize it, we'll sort this out, slide that right there. We'll increase our FS logics just ever so slightly, right? Give them a little extra storage space there for our backups. And that's it. There's really no additional adds to the environment. We are localizing, we're creating own host pools. Now, another approach is you could do these as personalized desktops, right? So instead of pooled, you go personal and then 10 named users, and then every user gets one of these. The obvious disadvantage of that is it, almost triples the cost, but then they're not sharing these resources anymore. So that is another approach you can take as well. But for best bang for your buck, looking at the scaling side of things, we want to do it this way, right? 4 hosts, shared 3 engineers at a time, and you could bring 2 more into the environment and still be okay. So that scales nicely. So I will save this and I will share this below. So a little bit of a shorter video, but all the information in there is just as relevant. You can reference previous design builds, which I'll put in the link below. Check the playlist if you have any questions. If there's a common design you would like to see, or maybe an application or even just a vertical that you'd like to sell into and you're not sure, let me know. I'll build a custom template for you. We'll throw it up on the channel and we'll see if we can get you into Azure. And with that, we'll catch you next time.